rectangular plot of land is 20 yards longer than it is wide, and it has an area of 800 square yards. What are the dimensions of the plot? So I was going to pop these up one by one. But here's the analysis. You'd say, what we would do today, the modern solution would say, let W be the width of the rectangle and let L be the length. So the length is 20 greater than the width. Okay, this is like the typical word problem that strikes fear in the hearts of young people all through the country. Whoops.
Or some not so young
And
anymore.
right, adults as well, even more fear in adults. But here it said, plot of land 20 yards longer than it is wide. So the length is 20 greater than the width. And the area is 800. So when you multiply, you get 800. Okay, well, what would we say? We'd say, well, if length is W plus 20, let's just put W plus 20 in for the length. So it's W plus 20 times W equals 800. And the standard algebra, bring the constant over, factor it if you can, and two things multiply to 0 when either one equals 0. A negative 40 would make this 0, and a positive 20 would make this. We don't take negative answers in geometry. You can't have a width of negative 40. So we would say the solution is 20 yards for the width. And then the length is 20 greater. So it would be 40. Again, it's, not my purpose today to teach you algebra, so maybe I went through that quick. But I think you can, follow, maybe recollect seeing things like that before. Well, how did the Babylonians do it? Part of what I'd like to do in a history of math class is try to get us out of this 21st century. They wrote in different numbers. We're not going to write in those numbers, but now you're aware. They wrote differently. They did it in base 60. Let's see how they would do it. When I write on the board, is it Ellie?
Ella, yeah.
Ellie?
Ella.
Ella, can you see when I write on the board?
Yeah.
Okay, because with the lights out, sometimes it's different. Great. Okay, so here goes. It's the same problem, and of course, the Babylonians would have realized, the length is 20 greater than the width, and the product is 800, and they would have realized that we could substitute this W plus 20 in for here. So, let's take it from here. Now, they didn't have algebra. Algebra didn't come along really. Of course, the scholars can debate the finer points, but let's just say till the Arabs came around 800, CE, the Common Era. Al-Khwarizmi, he writes the first great treatise on algebra. So the Babylonians 4,000 years ago didn't write x squared and stuff. So what did they do? They did it kind of like the Greeks did with geometry. Let me draw this a little bigger. So, what do they have? They have a rectangular plot of land. And you have the width, and the other side is the width plus 20. Okay, so this may look familiar to some of you. I've seen this before. So let's say this side, there's the W, and there's your 20. Okay. So what did they do? They said, you know what? Let's cut this guy in half. And let's take this piece and move it here. So let me just create another diagram so it's not too busy just yet. So here's W, W. Here's 10, and 10. Okay, right? I chopped the 20 in half, and I just put it there. Now remember, this whole thing is 800. Okay, so that hasn't changed. This whole thing is 800. Okay, so far so good. One thing I should mention, the geometry is kind of easy to follow. If you looked at that tablet, that one I had put up there, I'll just go back, we got modern technology. This is an actual quadratic problem tablet. There's quadratic problems on here. This isn't just some stock image. This is actually in the British Museum. It has a identity number and all. And as you can see by looking on it, there's no pictures. This picture isn't on there. They did it all in words. Kind of like sometimes in our classes today, the teacher just says, these are the steps you do. And sometimes it's hard to see why it works. So I'm showing you why it works, and they just listed the steps. They said, take this number and chop it in half. Then one of the next things they did is they said, okay, well let's the missing piece. And in algebra classes today, this is called completing the square, right? So this is 10 by 10. So let's just fill in and let's complete this square. Well, we're going to have to add 100 to the whole total. We just introduced something into the problem. So what do we have? This is a square now that's w plus 10 by w plus 10. Again, they wouldn't do it with algebra, but for us, I'll write it out. They just did it in words. They would say, take this resulting number and take the square root. Why? Because right now we have w plus 10 squared equals 900. And if you want to find the width, algebraically, we would just keep doing inverse operations till we get there. The Babylonians just told the students what to do. Take the square root of that number. I'll put it in our notation. Now, typically we show plus and negative when we do it today, but they didn't take negative answers or really work with negative numbers. So I'll leave it off, which is a little upsetting even to me, to leave off that plus minus. But you get 30. And then the instructions would have said subtract 10, and it would seem weird because the problem only had a 20 in it. But if you subtract the 10, you get w equals 20. And that's what we got with the modern approach that we did with factoring. And then the length, of course, would be 20 more than that. Okay? So we're talking today about solving the cubic equation. But this is how the Babylonians solved the quadratic 4,000 years ago. Any concerns with that? It's really not the most important part of the talk, but I think it kind of sets the tone. Okay, so Babylonians knew how to do this 4,000 years ago. What did the Greeks contribute to algebra? Again, if you read older books, they tend to say the Greeks had some algebra. The modern scholars tend to say we're really imposing our view onto the Greeks and they really didn't have algebra. Fair to say the Greeks didn't really have algebra. So they did have some problems that led to what we would call a cubic equation, and they tried to solve them geometrically. They tried to solve them with compass and straight edge, although you can't solve a general cubic with compass and straight edge, so the Greeks were stymied. But if you introduce other things, the conic sections, hyperbolas, parabolas, and circles, you can solve these geometrically. But that's not algebra. This is a talk about algebra. Ignore that. Next, let's talk about the Islamic Age. This is when algebra really began in earnest. Around 800 in Baghdad, they had the House of Wisdom. This is a place where they brought scholars from the empire. The Islamic Empire stretched from Spain to China. Huge empire. They brought translators who could, I guess, translate the Indian works. I believe they were written in Sanskrit. Translate the Persian works, which weren't written in Arabic. And translate the Greek works. The Greek works were still survived, and they had them. So there's this great translation school, and they're translating astronomy, mathematics, medicine, everything, and contributing to it. One of the persons who gets the credit for really beginning the codification of algebra is Abu Jafar Muhammad ibn Musa al-Khwarizmi. And he goes by the name usually al-Khwarizmi. And it translates to father of Abdullah, Muhammad, son of Moses, native of Khwarizm. That's a Russian stamp celebrating his 1200th birthday. And he wrote a book. And I won't read the whole thing to you. It usually goes by the name Hasib, Algebra, wal Muqabala. Now you might notice in there, Al-Jabbar. That's where we get our word algebra. When Europe finally translated it into Latin, they translated that into algebra. So it's interesting just to look at these two words. The linguistics, algebra translates as completion. We think of it as moving a negative from one side of the equation to the other and making it positive. Thank you. So here, again, you might recall from your algebra days, you could take this minus 2x. They did have subtraction. They didn't really think of negative numbers. But you could bring it over here, and you would add it as 2x and get 5x. So that's what algebra meant to them. Move the negative from one side and make it positive. To us, it's the name of the whole subject. And the other word in the title, al-muqabala, translates as balancing. We think of it as combining, when you have positive terms on both sides, subtracting the smaller from the larger. So here's a 2, here's a 4. If one of them was negative, we'd use algebra. But when they're both positive, we use al-muqabala, and you would subtract the 2. Subtract the smaller from the larger. So just a little interesting linguistics from the title of Al-Khwarizmi's work.